Geometric sequences are a lot like arithmetic sequences.
Really?
Really? Except you're doing something different here. What comes next? What do I do to get from here to here?
Times 3.
Times 3.
Times 3.
Rather than adding 3, we're multiplying by 3.
54.
54, good. Okay, so A1, the first term, equals 2 times how many 3's?
1. No, 0.
0. No raises here. This is more realistic. When you get raises, like it would be silly if your salary doubled every year, but it's something like that. You get it. You don't just get another $100 a year. You get a 4% increase and then another 4%. So this is more realistic. Your second year, how many raises have you gotten?
2 times
1, 3. A 3 equals 2 times how many 3's? It's 2 times 3 times 3, which is the same as writing A 4 equals 2 times 3 times 3 times 3, which is? So take a look here. This is always 3 to the 1, really. And technically, this is 3 to the 0. So this number up here is always 1 less than this number down here.
I just realized that.
Fantastic! Hey, better now than never.
Tomorrow.
It's all good. Okay? So what are we really saying here? A1 equals 2 times 3 to the 1 minus 1. A2 equals 2 times 3 to the 2 minus 1. A3 equals 2 times 3 to the 3 minus 1. A4 equals 2 times 3 to the 4 minus 1.
No, it's that.
Yes,
Are you
sir.
going to ask you that on the test or the first one?
I'm just doing this for explanations.
Oh.
Got you.
Yeah, no, we're getting to the point. So A5 equals 2 times 3 to the what?
5 minus 1.
A10 equals
2 times 3 to
the
10
9.
minus 1.
Yeah, 10 minus 1. AN equals,
2 times 3 to the n minus 1.
so that's where that n minus 1 term is. Don't be scared of it. It's saying 1 less than n is what that says.
Okay.
Multiply by 3, 1 less than n. In general, we say that this is AN, the nth term, equals the first term, that's all A1 means, times, before we called the thing, when we kept adding 3, adding 3, adding 3, we called it D, the common difference. What do we call it when we keep multiplying, multiplying, multiplying? Ratio.
Oh, got it.
So we all see where all these numbers come from? First term, ratio, n minus 1. First term ratio, 1 less than the nth term. Okay? So real quick, why don't we calculate the 10th term? Put in 2. We've already done 10 up there. How about the 20th term? It's going to be pretty damn big.
20th.
About the 20th term.
Is first term still 2?
Mm-hmm. Whose calculator can tell me the answer? Or is that too crazy big already? Should be a 9 or 9-digit number. How many millions or whatever? What is it, Zoe?
There's 10 numbers. It's 2, 3, 2, 4, 5, 2, 2, 2, 9, 3, 4.
How much is that? This would be 2,000. This is for what? Billions.
Oh my
These
goodness.
things get big fast.
Like this.
Okay. All right. So what happens happens, and again, this is the, let's review that real quick. This is the formula for the nth term. This says nothing about adding them up. This just says if I want the nth term, I gotta do it.
So, on the test, will you label like, this is a geometric sequence and like arithmetic, or?
If I were writing the question all by myself, I'd probably say, is this arithmetic, geometric, or nothing? And then say, if it is arithmetic or geometric, what's the nth term and what's the sum? And if it's nothing, then nothing you can do. That's
It
probably
doesn't
nothing.
multiply, the amount goes up or the, how it goes up.
Okay, what if we wanted the sum of these terms?
What happened?
What does this say?
K is your starting, oh no, it's
Mhm.
it's your starting.
So this says what in English? Just some words. What does the funny Greek letter thing mean?
10 is your nth term. You start with 1.
So who said funny Greek thing earlier or whatever?
Me.
Yeah. What letter is it? Do we know?
Said E, right?
It's a sigma.
E. Oh, sigma. E. I knew that shit.
What did he say?
The point is that it's a Greek,
Oh,
it's a Greek S, and it means sum. Talked about this before, and like in England, they don't say add 3 and 5, they say sum 3 and 5. It's the imperative, it's a command. So this means add them up. Okay, add up all the things that look like this, plugging in k equals 1, then 2, and then 3, and then 4, all the way up to 10. Okay?
Oh wait, no, 2 is your starting point, isn't it?
2 would be so this is the same thing, this is the same sequence we had before. So I'll break out the formula in a second. Oops, there it is. 2, 6, 18, 54.
So 2 is the A1.
So I'll write this out. The sum up to n, we'll put the k equals 1 in, of A1 times R to the k minus 1. Put that in. Equals, anyone remember the formula? The first term times I'm going to put parentheses around these to remind you. When you do it on your calculator, you need parentheses. Okay, so what's A1 here? 2. Good thing to put on your note card. Times 1 minus, what's R?
3.
3, good. To the,
What power would, which one was on?
so where's n in this whole thing?
10.
Good, 10 over 1 minus 3. Is the top positive or negative?
It's positive, right?
1 minus, like, 3 to the 10th? 1 minus a really, really, really big number? You're telling me that's positive?
I don't know, because
This is like 10 billion or
I guess
something.
not.
No,
I
no,
guess
no,
not.
no. Bottom, positive or negative?
Negative.
So what should the whole thing be then?
Positive.
Good. So plug that into your calculator.
I
Give
think
that
it's
a
doing
shot.
that like throughout the whole building, because it was like that in
It's so
the
weird.
room right next to the window. It's like a leak in the ceiling.
A leak in Abbey? Never.
Yeah, nah, it's happening. It's going down.
What do you got?
59,048.
1,048?
Yeah.
What is the 10th term of this sequence? It would be 2 times 3 to the what? Just for the 10th term?
10 minus 1.
Good. What does that equal? Better be less than 59,000. Probably about 30,000.
39,366.
Okay, so right there you got it. This adds up all the terms. This tells you what the 10th term is.
I think she might be.
Questions?